That screen you're looking at right now is the result of thousands of years of human ingenuity. Today, we're going to pull back the curtain on the fascinating and surprisingly long story of the computer.
You know, it can often feel like magic, right? But believe it or not, it all starts with a very simple idea, an idea that's actually thousands of years old.
So, how in the world did we get from these simple beads on a frame, to this, a complex machine of circuits and code? It's a huge leap for sure, but the whole story really starts with one simple core idea. To really understand that whole journey, we first need to get to the heart of what a computer actually is. And thankfully, the name itself gives us a pretty big clue.
At its very heart, when you strip everything else away, a computer is simply a machine that's designed to calculate things. That was its original and most essential purpose. And here's the thing. Every single computer, from the oldest mechanical gizmos to the smartphone in your pocket, really only does three basic things. It takes in some information, it does something with that information, and then it gives you a result. We call that input, process, and output.
Now, this whole idea of a calculating machine, well, it's not new, not by a long shot. In fact, to find its origins, we have to go back thousands of years, way before electricity was even a thought.
Our story really gets going with tools just like this, the abacus. Developed about 5,000 years ago, a lot of people actually consider this to be the world's very first computer, a totally manual tool for doing basic math.
So for centuries after that, you had these brilliant minds just building on that one simple idea. We started seeing mechanical calculators with all these intricate gears and levers, and even incredible steam-powered engines designed by Charles Babbage. These machines just kept getting more and more complex, learning to do more than just add and subtract, but to actually follow a basic set of instructions.
Okay, but the real revolution, the one that kicks off the journey to the device we're on right now, that all started in the 20th century. This is where we see the birth of electronic computers, and they've evolved in 5 really distinct stages, or what we call generations.
All right, Generation 1. It was all about one key component, the vacuum tube. It kind of looked like a light bulb, and its job was to control and amplify electronic signals, basically acting like a switch.
And when I say these early computers were big, I mean it is almost hard to wrap your head around. Machines like the famous ENIAC were just massive, weighing 30 tons, filling up entire rooms, and getting so hot they needed their own custom cooling systems. And on top of all that, they were really, really unreliable. Then, a tiny little invention called the transistor came along and changed absolutely everything. This was a real game changer. See, a transistor did the exact same job as one of those big, clunky vacuum tubes, but it was tiny, way faster, and so much more reliable. It used way less power and didn't burn out all the time. This one little invention was the key that unlocked smaller, more powerful, and eventually more affordable computers for everyone. So, things were already getting smaller and faster, right? Well, the third generation took that idea and just ran with it. Instead of using separate transistors, engineers figured out how to cram lots of them onto one single tiny piece of silicon. This was the integrated circuit, or what we just call a chip. And it didn't stop there. The miniaturization just kept going. Pretty soon, engineers figured out how to put the entire brain of the computer, the CPU, onto a single chip. This was the birth of the microprocessor, the exact technology that lets you have a super powerful computer on your desk or even in your pocket.
And that brings us to today, the 5th generation. This era is all about artificial intelligence. We're now designing computers that can actually learn from data, reason through problems, and talk with us in ways that feel much more natural, much more human.
So when you look at it all laid out like this, you can see this incredible pattern, can't you? With every single generation, the technology got smaller, the speed got faster, and the machines got way more reliable. It's just an amazing story of constant improvement.
Okay, so we've seen this incredible journey of technology getting smaller and more powerful. But here's the really cool part. All of this technology, from the oldest to the newest, still runs on that same super simple 3-step process we mentioned at the very beginning. So how does that actually work?
It really is this simple. Everything follows this basic flow. You provide some kind of input, like clicking a mouse or typing on a keyboard. The computer processes it, and then it delivers an output, like a letter appearing on your screen.
Let's make this real for a second. Just take a moment and think about the last time you used a calculator, maybe on your phone. The numbers you typed in, that was the input. The actual math it did, that was the process. And the answer that popped up on the screen? Yep, that was the output. It's the exact same simple pattern, it's just happening millions of times a second inside our modern devices.
And that thinking part, the processing? Well, that's all handled by one crucial component, the Central Processing Unit, or CPU. You can think of it as the brain of the whole operation, the part that carries out every single instruction.
You know, when you step back and look at the big picture, the progress we've made across those 5 generations is just mind-boggling. The scale of it is almost hard to comprehend.
This right here really puts it all into perspective. What once filled an entire room and weighed as much as several cars can now literally fit in the palm of your hand. We've gone from 18,000 fragile vacuum tubes to millions or even billions of tiny transistors on a single chip.
Yeah, this quote on the screen pretty much says it all, doesn't it? From those ancient beads all the way to modern microchips, the goal has always been the exact same: make our calculations smaller, faster, and more powerful.
So no matter how complicated it seems, just remember this. Everything a computer does, from playing a movie to guiding a spacecraft, just boils down to that one fundamental rule: input, process, output.
So now you know the story of the idea behind the computer, how it all came to be. The question is, what will you explore next about the machine itself?